Hey, built from scratch machine shop here. Happy Father's Day. All my obligations for the day are done, and so I'm going to be out in the garage working on a few more parts for our fidget chain. It is, I think we've got 96 of one of our pieces done, so that's enough for 20 of our fidget chains. I'm getting kind of bored running this part. That's the one thing that they don't tell you about manufacturing or machining is a lot of it is really cool and exciting, but then there's also just massive portions of it that just get boring. When you're in the middle of a run and you've got 1,000 parts to do, dude, that's 1,000 times you have to do something. Or if, like on those parts, we've done 100 of one, which means we have to do 300 of the other. And each of those has 2 holes, so we're going to drill 600 holes. It gets a little boring, and learning to deal with that in a machine shop is, well, it's a point of maturity as a machinist, is learning to be able to turn your brain off and just go. Um, probably, probably some of the most disappointing employment situations I've ever been in, where when guys learned that machining can be boring. That people are that I would say was probably the number one reason why guys quit at the factory I worked at is they were just absolutely bored out of their mind. Uh, that's one of the things that in the trades they don't tell you. We say, hey, go to the trades, makes good money. They don't tell you you have to be willing to be bored. It's not going to be entertaining all the time. If you are a production machinist, you are going to be bored. The machine that I ran, well, one of the milling machines I ran at the factory, for 3.5 years, I made the same family of parts. And of those, one part I made about 75% of the time. So when I came in, 75% of the time, I was making the exact same part. That's what it's like in a high volume, high production machine shop. Is you can get in there in some high volume runs or some frequent flyers, and you're going to be doing them all the time. And you're going to be able to look at that part and tell whether or not it's in or out of tolerance, even if you're dealing with something that's maybe a few thousandths tolerance, like these parts. It's floating around about 15 thou, and I can see 15 thou. 15 thou is 5 hair widths, and you would think that you can't see it, but if you've done this long enough, you can see it. You can see when something gets out of tolerance. And I had that part that I ran about 75% of the time, I could tell when the extrusions came in out of tolerance just by looking at the machining and how the machining looked. I knew exactly what was going on. One of the things they don't tell you is when they extrude parts, they came out and they look like wiggly spaghetti and they straighten them. And then, the speed that they're extruding it may change the width of the part or the diameter of the part. And we had some, and those those extrusions could vary by like 40 thou. So I got good enough and I was bored enough. I could tell you when the parts were in or out of print just by looking at them. Now, it doesn't mean that I didn't go through and do my QC checks on those. Always did QC checks. We were ISO 9001 certified, so we were a medical device manufacturer, so everything had to be done to spec. We did all of our inspections, but yeah, there were times I'd get bored. I'd have a run for 200 or 300 of this part. The part ran for like 6 minutes 30 seconds, and I knew I would be on it for days and just running that part. And then my break might be running half a shift of another part and then back to that same part again. Doesn't mean that was the only thing I ever done in the machine shop. I did learn several of the machines. I also taught myself conversational programming and did a lot of one-off jobs. Our factory, the parts we made, the owner of the company said that one of the things he promises buyers is that we would never outmode anything. Gosh, that sounds like an awesome idea. To the buyer and consumer, that's an awesome idea. If I buy a part or buy a machine and 40 years from now, you can give me a part for it. That sounds awesome. In practice, it sucks because you may have a box of parts in the warehouse and people may replace those parts, like 2 or 3 parts a year. and that box of parts may have had 40 or 50 or 100 parts in it to begin with, and you may not have run those parts. There may not be fixturing for those parts, and the last time we could have made them could have been 10, 15 years ago. And the boss would come out and he'd hand me a chunk of raw material. He'd say, hey, I need 6 of these by the end of the night. Here's a print. And I would have to build everything. I'd have to build the fixturing. I'd have to figure out what tools I need. I'd have to machine the parts. And by the end, I'd have to have these 6 parts. Sometimes we'd overrun the run. We might make 12 or 15 of them, just like, yeah, if we've got it set up and we figured it out and we're not going to run them again for like 4 years, let's make sure we don't run them again for 8 years. So, there were those rare instances, but most of the time machining is boring. It's very boring. High production machining is boring. That's why if you're going to go into machining, make sure you learn a lot of stuff so you can trade between machines. I began to be a trainer, which was really cool. So it allowed me to go on to other machines while I trained my replacements. But for about 3.5 years, I was bored out of my mind. But boy, did I learn machining and manufacturing. So anyway, let's go ahead and make some parts. Let's get Bard making these parts. I'm gonna make I might make like 10 more of this part, and then I'll switch over to a different design in the fixturing. And then if I need to make more of these, I'll come back to that. But I think I'm about tired out on this, especially if I'm gonna make 300 of the next part. I don't want to do too many of this one. All right, let's get set up. Okay, so let's see, we've got our chip brush. Get all those out of there. Get our drill press plugged back in. We'll get our oil. Like I said, I'm going to do about 10 more of these. So 1, 2, 3, 4, 6, 7, 8, 9, 10. And I'm going to put that part off to the side. Actually, put one back. Okay. All right, so let's go ahead and start this back up. Let's make some parts. Sure, I think that's in print. We'll go with it. We didn't even design a print for this one, but we'll do it. All right, there's our 10 extra parts. Let's go set you up on the bench tapper. Okay, we're going to get this all tightened in there. Get you back here where you can actually see it. And I've got my 10 parts. We're going to deburr them so they fit in our fixture. All right, that's all we need to do on that part. And I'll go ahead and machine the other side, and then we'll come back to the bench tapper. All right, we got the 10 parts run. We'll go ahead and deburr those other holes. Okay. Get that out of the way. Put our threading tap back in there. And put that form tap. We're doing the 632 form tap back in there. And shorten it up so you can get it all on there. All in your field of view. Okay, we're going to use our little hack together jig again. I think I can fix that. Okay. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 105, 106. So that should account for any of the issues. All right. Let's get some of the chips wiped off. Now, let's go back over to the drill press and get things set up for the next run of parts. So we're going to use part of this same setup. We may have to move our parts a little bit on here. Yeah. You're never supposed to grab chips with your fingers. I always forget, especially when machining at home and there's no big boss looking over your shoulder. You don't want to get chips in your hands. All right. Let's take this drill out. Let's do that so you can see. I don't want to move my Z height there. But I am going to... I'm going to have to adjust this slightly. So it may take us a little bit to dial this in for the next run. Okay, put some marks on there so I know which one's which. We're going to use that metal backing plate there. That one's not straight. I'll use another one of these here. You can always go all the way out there. All right. We're going to load in our pass-through size drill. Okay. We're going to have to adjust this so that it fits our parts right, because we don't want to break through the edge. We want it all in there. We don't want this moving around. Okay, so we're gonna drill this one as a test. We'll measure everything and see where we're at. Okay, so I'm pushing down and pulling towards myself. Let's get that one out. There's just not enough meat left on that, so I'm going to have to move that datum that way, which saddens me because I have it absolutely lined up as far as straight. Let's see how we can do this without moving it. I saw it move. Let's hope it didn't move too much in one direction. This is why having a mill would be really, really easy to dial this in. And I wouldn't have to drill parts and then move and drill parts and then move. It would just be set. Because I could just move the table in the X or Y. So, you know, the X or Y, we would move it rather than having to move our actual fixturing. Because this is not precision machining. This is making do. Excuse me. This is making do until we can get precision machining, because that's just not going to work. All right, let's move in there. That's much better. I think that's about it. Let me take a measurement on that. Get this tightened down so it doesn't move. All right, so this one sidewall was about 22 thou. This one, the sidewall is 55 thou. Let's see what this sidewall is. 40 thou. 35 thou. Oh, close to 40 thou. I think that's just about perfect. So let me go get one more piece of equipment. We'll try it with that. The pin is small enough to fit in these holes. I think that's our part still. Yeah. Yeah, oh yeah, we'll go through. So that anvil right there, that pin is at 0. So if I put this in here, 25 plus 11 is 36. 13. It's two. It only varies 2 thousandths. So to read a micrometer, each of those hash marks is 25, and then you add in the 13 there. So 25 plus 13. Yeah, 25 plus 13. So, yeah, we're right there. We're right there. That's perfect. What's this? 56 thou. Yeah, I can handle that. Okay. So our pin mic says we are good. So I'm going to go and run a bunch of these parts, and then I will come back and we'll measure them. We'll see how it goes. All right. So I got those holes drilled. They look fairly consistent. They do move around a little bit, but I think we're going to live with that. I think the only way for us to get around that is actually a CNC. And that is a while off, or just a manual mill and a better fixture. But I just kind of want to prove to you that you can start off with some real basic tools. You know what? I just thought of something. You know, you're seeing me use a bench tapper to deburr these parts, and it's spinning it. But you can actually do this by hand. I mean, you can actually come in, and I can do that same thing with just a countersink, and I can do that by hand. I use this because I have it, but really you could start up doing this with just a drill press, you know, and then just a few hand tools. But this definitely makes it easier. It's a time saver. It's a big time saver. So there's our 10 parts. We're going to go ahead and drill the other side, and we'll be right back. Okay, so we've got the other part drilled. Let's go ahead and deburr these. So we got the other part drilled. Let's go ahead and deburr them. There you go. There's 10 more parts. There's 100 of one, 10 of the other. But let's go ahead and let's go ahead and throw some of these together and see how they come out. So we've got our 632 screws. Oh, that's right. We got to have the threaded one on the bottom. All right, there we go. There is a length of our fidget chain. That's pretty cool. I think what I'm going to do is I'm going to take this last set out. I'm going to put it back on itself, just like that. I think that's pretty cool. So anyway, there we go. There is a length of our fidget chain. So I got some extra parts to work, and they all seem to fit together. So pretty happy about that. I'm gonna quit for the night, but I am gonna keep going this week and try to see how many of these I can get out. If you're interested, drop a comment down in the comment section, and I will get back to you when I think we're ready. We're not quite ready yet. I have a few more things to do, but I want to get a lot more of this fidget chain done, and we'll see how we go as far as the first product. But I'm pretty happy how it turned out. I think this will be enjoyable to play with. I've done some testing with it, handed it to a few people, not said anything, and just watched them play with it for 3 or 4 minutes before I said, hey, do you like that? And generally the response has been yes. So I hope you have enjoyed and learned something and enjoyed seeing us make our first product. Anyway, built from scratch, Machine Shop.